Section 11.3, Geometric Sequences. In this section, we'll find the common ratio for a geometric sequence. We'll list the terms of a geometric sequence, and we'll use both recursive formulas and explicit formulas to describe a geometric sequence. So we've talked about this chess example before, where the grains of rice are placed on the squares of a chessboard. And so on the first square, they placed 1 grain. On the second square, they placed 2. And then they just kept doubling it every time. So this is an example of a geometric sequence. So what is a geometric sequence? A geometric sequence is one in which any term divided by the previous one is constant. So in other words, each successive term in the sequence is obtained by multiplying the previous one by a constant called the common ratio. And usually it's denoted with the letter R. Okay, so let's take a look at why this is an example of a geometric sequence. If we divide each term by its previous one, 2 divided by 1 is 2. If we take a look at the next 2, 4 divided by 2 is 2. If we take a look at the next 2, 8 divided by 4 is 2. Every time we divide a term by its previous one, we get the same number, 2. And so 2 would be the common ratio for this geometric sequence. Another way of thinking about that is you multiply it always by the same number. So with arithmetic sequences, you add the same number every time, but with geometric sequences, you multiply by the same number every time. So, for example, to get the next term here, I multiply by 2. So every time we're multiplying by 2, the common ratio. So in general, all geometric sequences have this form that the nth term of the sequence is equal to the one that came before it times the common ratio. So which of these sequences, if any, are geometric? And if the sequence is geometric, find the common ratio. So one way to do this is to just start dividing subsequent terms. So negative 12 divided by negative 6 is 2. And then let's take a look at the next pair. Negative 24 divided by negative 12 is also 2. So we think the common ratio is 2. So now another way to ask it is, do we always multiply by 2 to get the next number? Well, negative 12 times 2 is negative 24. Negative 24 times 2 is negative 48. Negative 48 times 2 is negative 96. So this is an example of a geometric sequence where the common ratio is 2. Let's try the next one. 8 divided by 6 is not a friendly number. 8 divided by 6 is 1.666, I think. Let's take a look at the next 2. If we look at the next 2, 11 divided by 8 is not 1.66. This is something different. Why don't we go ahead and write down what this would be? 11 divided by 8 is 1.375. So we are not getting the same ratio every time we divide subsequent terms, so this is not geometric. Let's do one more. All right, so 0.25 divided by negative 0.125. Let's take a look. So 0.25 divided by negative 0.125. This is 2, negative 2. Let's take a look at the next pair. Here's the next pair. If we take negative 0.5 divided by 0.25, we also get negative 2. So we think this is geometric with a common ratio of negative 2. Let's just check. Negative 0.5 times 2 is 1. 1 times negative 2 is negative 2. So yes, this is geometric, and the common ratio is negative 2. Why don't you try this one? Is this sequence geometric, arithmetic, or neither? Go ahead and give that a try. Okay, let's check your work. So if we divide these two, 20 divided by 100 is 0.2. Let's take a look at the next pair. 4 divided by 20 is also 0.2. So we think it might be geometric. Let's just check. Is 4 times 0.2 the same as 4/5? And the answer is yes, it is. And so this was a geometric sequence, and r was equal to 0.2, or 1/5. Writing the terms of a geometric sequence. So write the first 4 terms of the geometric sequence where a sub 1 is 6 and r is negative 2. So the first number is 6. The second number is 6 times negative 2, or negative 12. Multiplying by negative 2 again, we get 24. Multiplying by negative 2 again, we get negative 48. So in general, geometric sequences can be defined recursively using this formula. A sub 1 is a number that's given, and a sub n, the next term, is r times the previous term. And this works where n is greater than or equal to 2. So let's take a look at an example of writing recursive definitions. Write a recursive definition for this geometric sequence. So first we have to write down what a sub 1 is. So a sub 1 is 6. And now we have to find out what r is. So 9 divided by 6 is 3/2. And let's just make sure that that's common for all of these. 9 times 3/2 is 13.5, so that works out. And so the common ratio is 3/2, or 1.5. So let's take a look at our recursive definition. So a sub n is equal to r times a to the n minus 1. So our recursive definition would look like this. This is equal to r. So a sub 1 is equal to 6, and the next term is equal to the one that came before times 1.5. Let's do one more together. Write a recursive definition for this geometric sequence. All right, so a sub 1 is 2. And now we have to see what are we multiplying by each time. It might be easiest to look at these two. What am I multiplying 4/3 by to get 8/9? R would be 2/3. Let's just make sure it works for the next pair. If I take 8/9 and multiply it by 2/3, we do get 16/27. So good. So r is equal to 2/3. And so the recursive definition would be a sub 1 is equal to 2, and a sub n, the nth term, is equal to 2/3 times the one that came before it. Here's one for you to try. Write a recursive definition for this geometric sequence. So remember, you have to write down what a sub 1 is, and then write down what r is. Okay, let's check. So we can see that a sub 1 is equal to 2, and let's see what r is. Well, you can see that if you multiply 2 by negative 3, you'll get the next term in the sequence. So a sub 1 is equal to 2, and the next term is equal to negative 3 times the one that came before.